the sun setting over calm seas on our first day of this expedition, we all wondered what the physics and biology would be like once we got out to the location of the bloom. It's about 8:45 in the evening. We're about to get on station. Greg and Matt were working pretty hard to find the location where we're going to put the sediment traps.
So we're in one of the labs of the ship, and these various computer screens here are giving some information to help tell us where we want to go. We started out by looking at a satellite image. So this is a satellite from up in space is looking at the ocean color. And in those maps we could see that there was some phytoplankton blooming in the water just south of Oahu. And this bloom is associated with a swirling large current in the ocean known as an eddy. And so one of our goals then was to go down and try to find the center of this eddy. And to help us with that, there's other instrumentation on the ship known as an ADCP, or an acoustic Doppler current profiler. And basically that's just an instrument that tells you which way the water is moving. So looking at this map here, this black line shows the cruise track that we have been following. And all along that track you'll see these colored arrows. And those arrows are telling us which way the current is moving. So as we move down here, we could see that the current was moving to the northwest. But as we approached the eddy, you could see the current starting to shift to the east. And so that told us that we were somewhere in this swirling feature known as the eddy. And ultimately, we wanted to get somewhere near the center. And at the center of a swirling eddy, the currents are very small. And so we could tell we got kind of lucky here. Usually when you want to find the center of an eddy, you have to do a lot of mapping and crisscross patterns. But we got fairly lucky. It seems like we may be close to it because the currents right now, as we're moving from the south and now we're starting to move to the northwest to get a little closer to the center, we see the currents dropping off rapidly. The currents here where we are right now are very slow. So we think we're close enough to where we want to be that it's time to put in the sediment trap.
Hi, my name is Brett Updike. I'm helping out with the Agouron course this year. We're going to get the students involved in the sediment trap deployment right now. It's about to happen in about 15-20 minutes. First thing we're going to do is pick up this big heavy weight at the end of this line. It's 1,000 meters of line. We're going to put that into the ocean, and as the line goes in, we're going to hook sediment traps to the line at 750 meters, 300 meters, and 150 meters from the surface of the ocean to collect sediments as they fall down through the water. Once we get the traps into the water, we get to the top of the line. We're going to hook it up to the surface floats here, which are then hooked up to this buoy, which stays at the surface and has satellites and radio transponders so that we can track it as it's out at sea.
Away the sediment traps go, the plan is to recover them on Friday, June 25th. Check back for further updates from aboard the Kila Moana.